Okay, so this video over here, we're going to be talking about polynomials and quadratics again. And first of all, just for this part, since we do need a bit of board space for a lot of these concepts, we're just going to go through using discriminant for this video over here, and we'll talk about using techniques to find the turning point in the next one. So what is the discriminant? Now, we use this triangle symbol over here, and we try to take a value out of the quadratic formula, sorry, not a quadratic formula, the standard form of a quadratic equation. And we say discriminant is equal to b squared minus 4ac, where all of these letters are the coefficients of our quadratic equation in standard form. Okay, so in each quadratic equation where you have 0 on the other side, you're going to have two solutions if your discriminant is positive. So not 0, it has to be greater than 0. One solution if it's equal to 0 exactly, and we say no real solutions when it's less than 0, because of course there are still imaginary solutions or complex solutions if it's less than 0. And we can use this concept over here to work out some interesting problems with a few literal equations. Now, if you have the equation, sorry, this should be 0. So for the equation 0 equal to 2x squared plus mx plus 5, we want to find values of n to start two solutions of x. Now, in this case over here, first of all, we need to work out the discriminant. So we know the discriminant is equal to b squared minus 4ac. On top of that, we also need to know what all these letters are. Now, our equation up here, or the expression on the right, is already in standard form. So this means we have a equal to 2, the coefficient of x squared. What's our coefficient of x? Simply m by itself. And we have our constant equal to 5. Okay, so we know all of this. We can calculate what the discriminant is equal to. So we have b squared, m squared, minus 4, a is 2, and c is 5. So this is equal to 40. Sorry, not 40. M squared minus 40. Okay, so we need to find some values of n here to make our discriminant more than 0. It has to be a positive number. And so we need to create an inequality here. So we need our discriminant greater than 0, or we can say that m squared minus 40 is greater than 0. Okay, to solve this, you can either use difference of perfect squares, or you can just take everything to one side. So in other words, I'm chucking the 40 to the other side, so we have m squared greater than 40. Now we can square root both sides, but we need to do a little bit of a graphical test first. Okay, so where's my red? Red is over here. Okay. If we have a graph of m squared minus 40, let's treat this as our m-axis. And so, it's going to be a parabola which intersects at 0, negative 40. Now you don't need to state your coordinates here, but just to be clear, we need a rough sketch to see where this curve is vertically above the x-axis. And we can see that the curve is above the x-axis, sorry, the m-axis, the horizontal axis. It's above the x-axis when it passes this point, and the parabola is moving outwards. So we know that our m values must be less than a certain number and greater than a certain number. And these certain numbers are found by finding out the negative and positive solutions of this inequality here. So over here must be negative of square root of 40 from 0. And the other one must be the positive square root. Okay. And if you were to write this in set notation, what we're going to end up with is m has to be less than negative. Now, root 40, just real quick, is equal to 2 root 10. I simply took out the 4 out of the third and treated it as 2 on the outside. So 2 root 10. And, or, it could also be greater than positive 2 root 10. Okay, so it's either of those two. And if m falls within either of these categories, then x is going to have two solutions. For one solution, this one's a lot simpler. All we need to say is m squared minus 40 is equal to 0. Because remember, this is a discriminant. Okay, so if your discriminant is 0, we want to find a value of m where all of this, find a value of m where this equation is true. Now, over here, similar scenario, m squared is equal to 40. And since it's just an equation, we just take the positive and negative square roots of the right side. So we have negative 2 root 10, or we have m equal to positive 2 root 10. Okay, so for no real solutions, again, we're going to be encountering inequality. So instead of having m squared minus 40 greater than 0, this time your discriminant, m squared minus 40, must be less than 0. Okay, so to work this out, again, I would recommend going to this step, where you have, if you have m squared less than 40, you need to see where the graph goes below the x-axis now. So below the x-axis because we need to go below where y is equal to 0. And we can see that it's from this point over here all the way to this point. And to define that interval, we say it's m is coming from negative 2 root 10. So m is greater than this, but it's also bounded by positive 2 root 10. So m is also less than 2 root 10. And that would be your final answer for no real solutions. If m falls between these two values, then you're going to have no real solutions for x in this equation up here.